I want to show you a couple of homework examples so that if you get stuck on those and you want some extra help, you can look for these videos. So this is one of the ones off the homework. We're going to solve this using variation of parameters, of course, because this function over here is not one of the three forms that undetermined coefficients works for. It's not an exponential, sine or cosine, or a polynomial. So as with any variation of parameters problem, we'll start by finding the homogeneous solution. So we'll write down the characteristic equation, r squared plus 9 equals 0. To solve this, just subtract 9 from both sides, and then r is plus or minus 3i. So this takes the complex form, so the solutions y1 and y2. y1 is going to be e to the 0t, since there's a 0 there. So that's 1, times the cosine of 3t, and y2 will be e to the 0t times sine of 3t. So once we have those, we know that our particular solution is going to look like v1 y1 plus v2 y2. And so to solve for v1 and v2, we need to start with the Wronskian. So that's the determinant of y1, y2, y1 prime, y2 prime. Right, so for this determinant, start by multiplying this diagonal here, and you get 3 cosine squared of 3t, minus, here we have negative 3 sine squared t, so the minus and the negative make that plus. And again, you'll notice that this reduces by the Pythagorean identity down to simply 3. And you'll see that happen with a lot of the examples in this unit with variation of parameters. Part of that is just that it makes the problems more doable, so it kind of keeps the difficulty from getting too high. So that, now that we know what the Wronskian is, we can find v1 prime and v2 prime using the formulas from earlier. So v1 prime is going to be negative f, which is the secant cubed, times y2, which is sine of 3t, divided by a, which is 1, times w, which is 3. So that's negative 1/3 secant cubed times sine. And we'll come back to that in a minute when we want to integrate to find v1 itself. But in the meantime, v2 prime is positive f times y1 all over a times w, so 3. So that would be positive 1/3 secant cubed times cosine. So now we can integrate these to find v1 and v2. So starting with v1, let me pull the negative 1/3 outside the integral. So we've got secant to the third and sine. To simplify here, just remember that secant is the same as 1 over cosine. So we can break this up as secant squared times secant, and then replace this secant with 1 over cosine. And then the sine and the 1 over cosine are going to combine to be tangent. So remembering back to Calc 2 and your integration methods, if we have a mixture of secant and tangent, that usually works out pretty well when it comes to integrating. So here's our setup so far. Then to integrate, remember that the derivative of tangent is secant squared, or that the derivative of secant is secant tangent. So either way you want to do it, let's say we let u equal secant 3t, then du would be 3 secant tangent of 3t, or 1/3 du would be secant tangent dt. So that fits exactly what we have here. So don't forget the 1/3. And that combines with the 1/3 we already have to give us negative 1/9 and then the integral of u du, so negative 1 over 18 u squared. And again, normally we would put plus c, but we don't need to because we're looking for any given particular solution, so we can assume that c is 0. So this would be negative 1/18 secant squared of 3t. So that's v1, and we'll come back to that in just a minute. Now we go to v2, and have to integrate this one as well. So again, we'll recognize that secant is 1 over cosine, so to simplify this, this just simplifies to the integral of secant squared. The idea is we can break off one of these secants as 1 over cosine, and that'll cancel with this one, leaving just secant squared. There are obviously other ways you could do this, but this is the simplest because the integral of secant squared is one we happen to know. Since the derivative of tangent is secant squared, the integral of secant squared is tangent. So this might be a little bit rusty from back in Calc 2, but if you go back and review a little bit, you'll see that you've done things like this before. So we now know what v1 and v2 are, which really means that our problem is basically done. We just need to write it all out in full form. So this means that our yp, again going back to this setup here, we know what v1 and v2 are, we know what y1 and y2 are, so we can write it all down. So v1 is negative 1/18 secant squared 3t times y1, which is cosine of 3t, and then plus v2, that should be 1/9. Sorry. Because of the 3t inside there, inside the integral, when you do a quick u sub, there should be a 1/9 there. 1/9 tangent of 3t times sine of 3t. So there's your particular solution, and then the full general solution would be that plus the homogeneous solution up here, the c1 cosine of 3t plus c2 sine of 3t. So there's just the particular solution. It's not the full answer. On the homework, they'll ask you for the full solution, but you've got the particular one here, and then the homogeneous pieces up here. And so put them all together, and you've got your full solution for that one. There's another problem, the next one that you should see. Which looks like this. All right, so again, we're going to start by getting the homogeneous solution. Notice here, before we go any further, that you might try to think about doing this with undetermined coefficients, but this actually isn't a polynomial because the exponent is negative. So it's a slight distinction, but it turns out it would throw off your undetermined coefficients method. So variation of parameters is the way to go here as well. So again, we're going to start by finding the homogeneous solution first. The characteristic equation looks like this. And then to solve that, we can factor or use the quadratic formula or whatever you want to do, but this is the same as r minus 4 squared. So that means r just equals 4. So our two homogeneous solutions are e to the 4t and t e to the 4t. Which means now we can find v1 and v2. Of course, we have to find the Wronskian first. So here's y1, y2, y1 prime. And then to do y2 prime, we need to use the product rule, but you should be able to see that, well, let's do it in detail. So when you take the derivative of t you get 1, so you get e to the 4t plus t times 4 e to the 4t. So we can factor out an e to the 4t just to make things a little bit easier to work with. So that looks like our Wronskian. And then to take the determinant, again, we take the product of this minus the product of that. So the first part, we multiply and get 1 plus 4t. E to the 4t times e to the 4t, remember that would be e to the 8t. And then multiplying the second part, so we're going to subtract. When we multiply these, we'll get 4 times t, and then e to the 4t times e to the 4t again is e to the 8t. So notice what happens here. We have e to the 8t plus 4t to the 8t minus 4t to the 8t. So these cancel each other out, and all that remains is e to the 8t. So that's our Wronskian, the value of w. Which means we're ready to find v1 prime and v2 prime. v1 prime is going to be negative f, so negative all of this times y2 all over a, which is 1, times w, which is e to the 8t. And v2 prime is going to be f times y1, which is e to the 4t, all divided by a, which is 1, times w, which is e to the 8t. Now notice how these things simplify. Here on this first one, the t to the negative 7 and the t make t to the negative 6. And then all the e's cancel each other. So e to the 4t, e to the 4t on the top make e to the 8t, and that cancels with the 1 at the bottom. And the same thing happens with v2 prime. All that's left is t to the negative 7. So these are relatively simple, very easy integrals to do. So the last step will be very quick. v1 is the integral of negative t to the negative 6th. So that will be 1/5 t to the negative 5. Again, normally we would put plus c, but we'll assume that that's 0 for simplicity. And then v2, the integral of t to the negative 7, which is negative 1/6 t to the negative 6. So we got v1 and v2. We have y1 and y2. So the particular solution then is going to be v1 times y1, which is e to the 4t. And then plus v2, so minus 1/6 t to the negative 6. E to the 4t. So then the full solution would be the combination of the homogeneous solution and the particular solution, the non-homogeneous version. So that would be c1 e to the 4t plus c2 t e to the 4t plus all of this. I think there's something missing here, but I'll try to go back later and find a mistake. But I don't think that's exactly right. I don't see where I made a mistake. So that may be correct, or there might be a slight mistake in that. If you notice that the homework question isn't quite right, let me know.